This summer, my group focused on medical Internet of Things devices, and we researched how to secure those devices against cyber attacks on the home network. My name is Excel Alale. I'm the REU participant of this group.
Hello, my name is Don Reeves. I am the RAT participant. Our mentors are Paige Harvey and Ottilie Tusa, both doctoral students, and our advisor is Dr. Kevin Cornegay of the CREAM Lab here at Morgan State University.
Here are talking points for this presentation. We are going to begin with an introduction, then we'll talk about our project goals. We're going to talk about our attack scenarios, an OSI breakdown of those scenarios, our technical approaches, demonstrations, results, mitigation recommendations, moving to the classroom strategies of our RET participant, future work considered, and our closing remarks. Introduction. Internet of Things are devices that can communicate over the internet. They have embedded systems installed on them, and they're able to send back and forth packets containing information to be able to communicate with each other. This summer, we used the Raspberry Pi, iELF smart glucose meter, an Alpha Wi-Fi network adapter to perform 3 attacks: the man-in-the-middle, phishing, and spear phishing attacks.
Our project goals basically is to prevent any unauthorized attack or control of these medical IoT devices in the home environment. These attacks could be as listed: attacks on the patient's medical information, the device and communication control. In attack scenario 1, someone is diagnosed with diabetes and the doctor recommends that he purchases an iHealth glucose monitoring system in order to control or monitor his treatments. The attack we're going to consider is a man-in-the-middle attack. And we want to prove that although there are benefits to the medical IoT devices, the device could also be at risk. And we also want to apply a defense to these attacks.
In our second attack scenario, we have 2 networks set up. We have the patient's network and the hospital's network. We're going to exploit both networks to gain access to them from either the patient's smartphone or the doctor's computer. We're also going to try to intercept, modify an email communication directly from the smartphone app to the doctor's computer. We're going to try to gain access to these using phishing and spear phishing attacks. On the OSI layer, our phishing attack takes place between the presentation and application layer, which are what directly pops up on the victim's screen. Our spear phishing attack ranges from the presentation to transport, which ranges from what pops up on the screen to the communication between 2 devices. And then the man in the middle tries to exploit between the physical data link, network, and transport.
Our technical approach began by understanding Kali Linux. We also want to understand the iHealth communication. We set up our iHealth glucose meter, set up an account, and we set up Kali Linux on our Raspberry Pi. We also set our Raspberry Pi up as a wireless access point and installed 2 packages, the host APD and the DNS math package, to set up our new access point. And we want to understand our attacks. 2 challenges we had. The first challenge was to install Kali Linux onto the Raspberry Pi and also setting up the wireless access point. Based on our architecture, using the man-in-the-middle attack, the victim or the target, which is our iHealth glucose meter and app, will communicate with the wireless router, our Raspberry Pi. The attacker is going to use ARP poisoning to perform the man-in-the-middle attack between the victim and the wireless router. To perform our ARP poisoning and man-in-the-middle attack, we use a tool called ARP spoofing. ARP spoofing is a tool that allows us to redirect traffic from our client or our victim to our device. And we can perform that man-in-the-middle attack and sniff the traffic or gather the information.
Our second man-in-the-middle attack, we used Wireshark to view communication happening over the internet. And then we used Kismet along with Wireshark to be able to sniff and detect packages and packets containing the email communication, and we're able to modify it and also view it. For our phishing attack, we used the social engineering toolkit on Kali Linux, but configured it to work with an Internet of Things device and be able to clone the iELF lab login page to our Raspberry Pi IP address. So our Raspberry Pi served as a server for the page, and we used EtherCAT to be able to redirect victims on the network to that IP address rather than that legitimate iELF labs login. For the spear phishing attack, we used a social engineering toolkit available on Kali Linux, but configured it to send a malicious email to the victim and launch a Windows reverse TCP shell which will send back the login of the network and also the login of the computer back to the attacker. This way, the attacker is able to gain access to the doctor's network, which eventually could lead to the hospital's network infrastructure. Next, we'll be showing two demonstrations. The first of a man-in-the-middle attack where using ARP poisoning, and the second, a phishing attack.
In this demonstration, we typed in DNS mask to start our server. Then we typed in IP route to list the static IP addresses for which we want to perform our attack. Then we listed our net discover to discover devices on which I would like to perform the attack. And what it does, it lists the IP address and the MAC addresses of which I like to do the attack. Finally, we initialize the ARP spoof command, where I represents the interface, in this case WLAN 0, T is for the target, the IP address of our victim, and R is for the default gateway.
In our second demonstration, we're showing a phishing attack. The victim connects to the Raspberry Pi IP address, and the Raspberry Pi acknowledges that a device is connected. However, now the victim tries to connect to a highoutlabs.com site, but the Raspberry Pi identifies the same device twice for connecting. Then the victim proceeds to enter their login information on the legitimate iHealth Labs site. However, the Raspberry Pi grabs that login, and the Raspberry Pi is able to secure that login. This way, a phishing attack has just been performed on the victim.
Our results are using ARP spoof tool. We were able to trick the glucometer to communicate with the attacker rather than the router. And if you notice right here, this is the information that you know that I'm sending information to the glucose meter as if I am the router. We found two recommendations from the NIST and the IEEE. The NIST article, 5 Steps to Cyber Security for IoT Medical Devices, and IEEE, no phishing beyond this point. As a high school teacher, I would like to introduce my students to the Raspberry Pi, allow them to build a computer using the Raspberry Pi and browse operating systems, to set the Raspberry Pi as an access point or wireless access point, and create a network between two IoT devices. I want the students to use Wireshark to spy on communication and to perform a man-in-the-middle attack.
And for future work considerations, we would look into how to utilize machine learning tools to automate cybersecurity on the medical devices and also on the network.
I found this experience very great, learning more about the Raspberry Pi and also about cybersecurity.
Working with the Cream Lab this summer was a really awesome experience, and learning to understand connectivity control and communication protocols on IoT devices will help me in my undergraduate classes. And finally, these are our references.